Hey everyone, it's Michaela. For my sickle cell education assignment, I done an educational booklet and also done two kind of loose parts demonstrations. We'll talk about them later after we go through the book. So my book starts out, says, "Hello, I'm Nurse Michaela and I'm going to explain sickle cell anemia." To understand sickle cell anemia, we have to have a lesson in the circulatory system. What is the circulatory system and what does the circulatory system do? The body is made up of many systems that help it function. The circulatory system is a body system that allows things to travel through the body, blood and lymph. The circulatory system keeps blood, oxygen, and nutrients flowing through the body. The circulatory system is made up of the heart, blood vessels, blood, lymph, and lymphatic vessels. The circulatory system is a network of organs and blood vessels that act as both a delivery and waste removal system for the body. Delivery. The blood circulatory system delivers nutrients and oxygen to all the cells in the body. Waste removal. The circulatory system removes waste products like carbon dioxide. Next, we'll talk about the blood that travels through our circulatory system. What is healthy blood made of? Blood is made up of liquids and solids. The liquid part of the blood is called plasma, and half of our blood is plasma. The solid part of our blood contains red blood cells, white blood cells, and platelets. And you can see in the picture some of the red blood cells, white blood cells, and platelets. And this part is plasma. So next in my book we go through the types of blood cells. There's red blood cells, and they're also known as the ones who deliver the oxygen, so they're the delivery men. White blood cells fight infection and are part of your immune system. You can think of them kind of as the guards. Platelets, you can kind of think of them as the construction workers. They help to build blood. They help the blood to clot, and they help to build a scab. Next is how blood is made. Bone marrow, the spongy material inside your bones, makes new blood cells. Blood cells constantly die and your body makes new ones. Red blood cells live about 120 days, platelets live about 6 days, and some white blood cells live less than a day. So here in the picture you can see this is the bone marrow, so this is where the blood cells are formed. Next we start talking about the blood types. There's 4 blood types: A, B, AB, and O, and these are important for when you go to have transfusions. So now that we know a little bit about our circulatory system and blood, we can talk about sickle cell anemia. Sometimes when our body's not working right, we don't feel good and have to go to the doctor. And when we go to the doctor, they run a lot of tests, including blood tests. Blood tests such as blood count tests can help doctors check for certain diseases and conditions. Sickle cell anemia is diagnosed through a blood test. Next, what is sickle cell anemia? Sickle cell anemia is an inherited blood disorder. It is a condition where there isn't enough healthy red blood cells to carry adequate oxygen throughout the body. Hemoglobin is a protein in red blood cells that carries oxygen through the body. With sickle cell anemia, the hemoglobin forms into stiff rods with the red blood cells, and this changes the shape of the red blood cells. The red blood cells are supposed to be a disc shape, but the changing of the hemoglobin turns it into a crescent or a sickle shape. So next we talk about what a sickle cell is and why it's problematic. Normally your red blood cells are flexible and round, which make moving through your blood vessels easy. The sickle cell shaped are not flexible and cannot change shape easily. In sickle cell anemia, the red blood cells become rigid and stiff and are shaped like sickles or crescent moons. These irregularly shaped cells can be problematic because they get stuck in the blood vessels and can slow and block blood flow to oxygen to parts of the body. So here you see a normal red blood cell and the hemoglobin in it. And over here we see a sickle cell with the hemoglobin in rigid stick-like lines. And here you can see why it's problematic. Here's a blood vessel, and you have your red blood cells and the sickle cells. And the sickle cells are forming blockages to where the normal red blood cells can't get through to deliver oxygen to different parts of the body. How does one get sickle cell? The cause of sickle cell is a defective gene called a sickle cell gene. People with this disease are born with 2 sickle cell genes, one from each parent. If you have one sickle cell gene, it's called a sickle cell trait. People born with sickle cell trait are generally healthy, but can pass the defective gene on to their children. Who's at risk for sickle cell? In the United States, most people with sickle cell anemia are African Americans. And here in the diagram, you can see, here's the little key up here that says normal hemoglobin gene and a sickle cell hemoglobin gene. Here's each of the parents. Each of the parents have a normal and each have a sickle cell. And so down here are your chances of inheriting sickle cell anemia. So you can have no sickle cell anemia, you can carry the trait, or you can inherit sickle cell anemia. So next we start talking about the signs and symptoms. Some of the signs and symptoms is anemia, which is you feel fatigued, no energy. There's also episodes of pain. The pain usually is in arms, legs, belly, chest, hands, feet, and lower back. People with this can also have painful swelling of the hands and feet, frequent infections, delayed growth, vision problems. Over here we can see he has feet swelling, some back pain, hand swelling. Symptoms may vary from person to person. When you should seek medical care: unexplained episodes of severe pain, swelling in your hands and feet, abdominal swelling, fever, pale skin, yellow tint to skin, and signs or symptoms of stroke. Next, we'll talk about what factors contribute to sickle cell crisis. It says crisis can be brought on by high altitudes, dehydration, illness, stress, and temperature changes. Often a person does not know what triggers or causes a crisis. So here we have a person with high altitude, dehydration, stress, and temperature changes. What can a patient do to decrease the likelihood of sickle cell crisis? They can take folic acid supplements, choose a healthy diet, drink plenty of water, avoid temperature extremes, and exercise regularly. A cure for sickle cell anemia, really you just are treating the symptoms for most people, but some people have stem cell transplants. And stem cells are just undifferentiated cells that have not turned into a specific type of cell yet. Some of the treatments can be to relieve pain. Treatments are antibiotics, pain relievers, childhood immunizations, and blood transfusions. And Sickle Cell Disease Awareness Month is in September, and that's the end of my book. Next, we can go through the loose parts. We'll start up here with this one. This is just made out of corn syrup for the plasma, hot tamales for the red blood cells, and these type of nerds for the white blood cells, and nerds for the platelets. Okay, so here in our little mixture, this is our plasma, and there's a red blood cell, and then there's a white blood cell, and then these nerds are the platelets. And over here on this loose parts demonstration, I made 2 separate blood vessels. The blood vessels I made out of Twizzlers, Lifesavers, those type of nerds, and the littler nerds. So over here we have a normal red blood cells in this vein. You can see they're normal because they're the disc shape and there's no blockages, and so oxygen is able to flow through the veins and to other parts of the body. Over here in this vein we see crescent shaped red blood cells right here, and having crescent shaped red blood cells causes blockages. As you can see here, they're accumulating right here, and that doesn't allow for the normal blood cells to flow through to the rest of the body. When we have blockages like this is when the person can have severe pain, and so that's my loose parts demonstration and my booklet. Thank you guys for listening.